And every question that you're going to be answering under power supplies is going to be considered from the circuit that you're working with. It is very, very important that you understand the type of the circuit that you're dealing with. In this case, we're going to be considering power supplies from the question paper of February 2022 exams. We want to see how are we supposed to answer these typical questions. Let us see. We are given, in this case, an RC filter. In this case, that is, we are talking about, we've got resistor and capacitor condition. Given a resistor and a capacitor, filtered the output at the output of a half-wave rectifier. All right. From the half-wave rectifier filtered at the output, okay, the first capacitor filter develops 28 VDC, which is the voltage, and the RMS voltage, which is given as 2 volts, ripple voltage at 60 hertz frequency in this case. All right, that is the information that we're given in this case. And let us just consider having our circuit. In this case, we are talking about an RC filter in this case, where we are going to be having something of this nature at the input, which is the rectifier. It's actually the rectifier output that we are having here to the resistor. So you're gonna have our resistor here, gonna have our capacitor, which is the first capacitor, and we are going to have another capacitor here. So here I'm just gonna have a sketch, right? All right. So we are going to have capacitor C2, which is the second capacitor, to the load resistor in this case. All right, this being connected to the load resistor. All right, so that's something of this nature. Okay, I'm just going to show you again this part. So this is what you're going to be working with, whereby this is our load resistor. We've got the second capacitor, the first capacitor, and our resistor in this case. And this is where we are having the output that is from the rectifier in this case. So it's our input here, but being the rectifier output that we are having. So we are given the resistance here of 120 ohms. That is our resistance of 120 ohms. Then the capacitor value, which is of 210, filtered at the output of a half wave, meaning to say from this, because remember I said this is the rectifier output. So here we are talking about a half wave that is output. So there we are given the value of the capacitor C1, which is 200 from the output of what? From the output of the rectifier, which is our input to the filter in this case. All right. Then we are given that after that, the first capacitor develops VD, meaning to say across C1, if we are dealing with C1, the voltage, which is the output voltage there, is given as 28 volts, and also VRMS there. This is our ripple RMS. All right, it's going to be 2 volts. All right. At a frequency, we are also given the frequency of 60 hertz. All right. And the question here is to calculate or to determine the output ripple voltage. In this case, we are supposed to calculate the output ripple voltage. Remember, we have the ripple voltage here, which is the input. This is across capacitor 1. Remember, we're talking about capacitor 1. The output is supposed to be across the capacitor what? Across the capacitor C2. That is where we are going to have what? The ripple voltage there at the output, which is given by the symbol from the output that we have. We are going to have the output from that capacitor. Remember, this was the output from the voltage that we are considering from that of an output of the rectifier. Now we are talking about output from the filter on its own. So this we can consider from this, just write it as V bar like this. This is our ripple output voltage, which is our RMS voltage. All right. So the question is, how are we going to calculate this? This is item 1, item 1. All right. So 4.11. Okay. How are we going to calculate this value? All right. If you are to consider, I just want you to go back to your revisions there. I want you to see something here. This is the part that you're talking about, an RC filter here. All right, which is our circuit, and also given the purpose and operation and so forth. If I want us to consider the calculations and so forth, I want us to explain on this formula that we are given. This is the formula for a RC pi filter, this one. All right. Here we are given some of the formulas, in fact, all of the formulas that we need to consider as we are dealing with what an RC pi filter. So at the output, we are having this VR ripple RMS, which is given as XC over the square root of R squared plus XC squared times VR RMS, which is the one that we are given. So we are going to consider this formula here. All right. That is the one that you're going to consider. For a what? For a half wave now, XC is supposed to be considered as 1 over 2 pi FC. And as we are talking about from a half wave, if it was a full wave, we're going to consider our XC as 1 over 4 pi FC. So in this case, we are going to consider XC because we are going to need XC here, but that XC, we're going to take it 1 over 2 pi FC. All right, so this is what we are going to consider for the output in this case. Remember, we are to calculate the output in this case. So that this output voltage is going to be given by the formula XC of the square root of R squared plus XC squared. All right. So if we are to consider our formula, we are going to see that XC, we do not have this value. And as we are to consider that this is taken from a half wave, so we saw that the formula for XC is going to be considered as, let us see if our calculations here, the formula for XC is going to be taken as 1 over 2 pi FC. If it is a full wave, it's going to be 4 pi, all right? So that's our XC is going to be 1 over 2 pi times the frequency, 60 hertz in this case, times the capacitance value at C1. Remember, the capacitor value across C1 is 210 microfarad. So we are going to use that 210 microfarad, that's times 10 to the exponent of -6. All right, so there we are going to obtain the value of XC, which is going to be 12,6344, like that, 3143133 and so on. So it's going to be 631 to 3 decimal place. That's in ohms in this case. All right, so having the value of XC, which is our capacitive reactance, we are going to substitute here because we have the resistance. Remember, the resistance here is 120. So we are going to use the resistance of 120 there. So that's it. Our output ripple voltage is going to be given, RMS voltage is going to be given as XC, which is 12,631 over the square root of R squared. Remember, our resistance is at 120 ohms. So as you see, it's all about the formulas that are required. That's why I'm giving, or I'm bringing you back to your textbook so that you can see where exactly are you supposed to be revising along. All right, so that's it, guys. You're going to have your output voltage in this case. All right, this one is just, you were talking about the reactance is only, we are supposed to multiply by what? By the ripple, that one that we are having, which is our DC, the RMS value that we are given here, which is across capacitor C1. Okay, sorry for that. I'm seeing now to say here, we are just having, these are just reactances only. So meaning to say our VR in this case is going to be what? 2. Okay, so you're going to multiply that. You must obtain something like 0.209 volts in this case. All right, so that is it. That is it, guys. That is how we're supposed to play around to calculate the output ripple voltage. And here we need the input ripple factor. All right, so we are considering of the input ripple factor, which is R in this case. All right, where do we obtain R? I want us to get back to those formulas again so that we can see where this is being taken. So our ripple factor is going to be taken from which formula exactly? All right, so I do not want to waste much time. Let's check here. This is where we are having remember they said at the input. So if you are talking about at the input, you are talking about across R1. If it is at the output, we are talking about this across C2, which means we are going to use it as R bar, that is like this. So in this case, we are going to use our VRMS, the ripple, that is our voltage over the voltage at the output in this case, which is our VDC in this case. All right, so we have these values, isn't it? We have, let us get to the formulas and our diagram also. Let's see what we got there. So we have, in this case, if we are to check our formula, is stating we are going to have VRMS over VDC in this case, all right? That is what you're going to have at the end. Let's check. We calculated all this, or we have. Okay, remember here, our VRMS is given as what? 2 volts. We have this from our given information, that is 2. And our VDC, in this case, we also have it as 28. So this, everything is there. This one, guys, everything is given. So that's it, 2 over 28, simplify. You are going to obtain 0.071428, like that. All right, which is going to be 0.071. All right, so that's our input. If it was at the output, meaning to say you're supposed to consider at the output in this case, okay? So take note, here we are referring to the input. So we are talking about across what? Across capacitor 1. So this is taken across capacitor 1. Okay, so be careful. Like I'm saying, each and every part is important in this. If you are dealing with power supplies, guys, you have to work with the diagram. Each and every diagram, you have to know it. All right, 4.2, we are given, calculate the load current of an LC pi filter with 210 volts across the input capacitor. The choke is an inductor with a resistance of and output DC voltage of this. All right, so this is what we are given. Remember, we are dealing with an LC pi filter. I shall also show you the diagram later on, but just for a sketch purpose, we are supposed to be having something of this nature. We've got our capacitor here, C1 again. So you shall be talking of the voltages which are from the rectifier output. All right, so here we shall have it from the rectifier output, and we are given this is all right, input and so forth. All right, so when it is not important, meaning to say here we just need to know this is from the rectifier output here from, okay, this is from, so this is an input, but it's from what? From the rectifier circuit. All right, from the rectifier circuit in this case, or the rectifier output. All right, so that we can understand each other. From the rectifier output, we have got the input, all right, which is going to affect across capacitor 1 in this case, whereby we're going to have the input voltage, which is IDC there, and also here we've got VDC across C1. Okay, then we have got the inductor, which is the choke has got the inductor and a resistor. So we're going to have an inductor and a resistor at the same time here, whereby inductance here is given as what? 10 henries. So this is 10 henries. The resistance is given as 200 ohms. And the output DC, now we are talking about output. Remember the input DC here, and we're going to have the output DC. All right, so the output DC is after capacitor C2 across the load. Here we're going to have our load resistor. Okay, so meaning to say this is where we have got our C2, and we can have the voltage across here, which is the output now DC, like this. Okay, so as we can see, we also have the current at the output. Here we've got the current at the output, and I think that's it. This is the choke that we have. So we are given what here? We are given the output DC is 162. So this one, the output is 162. This one is 162. Let us just write it aside. we are given the input, okay, which is our VDC, which is the input of 210 from what? From the rectifier. Then the output, in this case, after this filter, the output is at 162 ohms. So the question there was calculate the load current. Okay, this is a direct question. This one is not even what we are supposed to be working with like this, that way that we are playing around with this like this. Okay, anyways, this is what you're gonna have. Like I said, I'm going to bring you back to your formulas again so that you understand, guys, where are we coming from and where are we going. Okay, this is an LC pi filter that I'm showing you here from our textbook. What is important here, according to the diagram, this is the diagram. We've got the input and also the currents and voltage at the output in this case. All right, so there are formulas that are important also to consider on this part. All right, these are the formulae that we are going to be considering about the output. So we have got two formulas that we are supposed to consider for the output voltage, which consist of the current in this case. All right, so this one, it consists of the current that we want to find, which is the input, which is we can use this one if we are given RL, this we want to calculate the output voltage. But if you check, there is no current here, so it's not wise for us to use this formula. Okay, so the best formula that we are supposed to use in order for us to obtain current was this one for the output voltage. All right, so I'm just gonna write this formula aside so that we consider it together. So please do not forget our formula. So remember our formula here, that's 4.2 in this case, 4.12 or 4.2. All right, this is 4.2, sorry. So the whole of this part is 4.2, sorry for that. The whole of this part is 4.2. I've already written it here. All right, so we saw that the voltage at the output in this case, which is VDC, can be given as the input voltage minus the input current times the resistance in this case at the load, which is R. That is our R, not RL, but R in this case. Okay, so if we are to consider this part that we are given, if we are to consider this, we can be able to calculate the value of any part here according to what we are given. All right, so that means we can calculate the current, because here the question needs us to calculate what the load current, meaning to say our load current, which is IDC there. We can be able to calculate it from this formula. Let us make it the subject. We're going to transpose VDC to this side at the input. So it's going to be output minus input. Okay, so here it's not going to work because it's going to give us a negative. I want to avoid having this as a negative. So let's transpose this to this side so that it becomes a positive. All right, so we are going to have positive this, which is equal to the input minus the output in this case. All right, so this is our output. Then to find the current, which is our load current, you can simply divide by what? By R. So you can simply divide by the resistance here. That means our load current is going to be the input voltage. We have got 210 minus the output at 162. Why am I using ohms for a voltage? Okay, now I'm tired, guys. Okay, this shows that someone is tired here. All right, so anyways, that's it. Divide to the resistance. Okay, we're gonna have our resistance of 200 at the choke there. Our resistance is 200 ohms. Okay, so that's it. Gonna divide. We have got our load current, which was going to be 0.24 amps. So this was going to give us 0.24 amps. So guys, also bear in me when I'm writing wrong units there, because of this time to be working there and there, but I just hope we are together, guys. Okay, 3 marks for that. That was 3 marks. Okay, if you check the 4.3, we are still again on the same filter, because here we are considering but I can just remove this part because it's not on this second part. we are considering same situation of the circuit in this case, but not to say these values they are to remain, because here they are still talking about what? Calculate the output DC of an LC pi filter, meaning to say we are still on the same part here, but this time we are supposed to calculate the output DC. Remember, we on the last part that we checked there were two formulas that we can consider. This time, if you check what we are given is with the choke resistance, we are given the resistance of 180 ohms and 1,500 with the load resistance. In this case, we've got the load resistance that is RL here at the load. So this is our RL, 1,500 ohms. The voltage across the capacitor is 200 volts in this case. So that is the voltage across the capacitor, which is our VDC is 200. They can't give us this because this one that they are asking to calculate. All right, so which is going to be the best formula now? Are we going to consider the last formula that we used? No, because there, that formula, we had the current, if you check, we had the current, so we can apply that. But now it's going to be difficult for us to apply this formula. So meaning to say, we are going to apply which one? Okay, let's consider the second one. I want you to see this part that we talked about again. All right, if you check here, we were talking about here on our filters here. We're talking about finding the output voltage, which means we can use this formula or this one. This one, this time is the best because we have everything here. Everything is there. RL over RL plus R times this we've got. Which other L's that we can use? There's no formula here. Okay, we do not have the VRMS at the output. So meaning to say, in order for us to have the output, this is the best formula that we can consider. All right, so let us apply our formula, guys. As you can see, it's a matter of knowing your diagram, and each diagram has got its corresponding formulas. And I just wish, guys, you can be able to know each and every part so that you won't struggle on your exams. All right, so we saw that this time the best formula to use for the output voltage is going to be from RL over RL plus the choke resistance, in this case, times VDC, which is the input voltage. And we have everything according to the information that we are given. So therefore, the output voltage was going to be RL, which is 1,500 over RL plus R, which is 1,500 plus R, in this case is 180 times VDC, which is the input of 200 volts in this case. That's it. We are going to have our output in this case. So that means our output is going to be taken as, that was going to give us something like 178,571, that is 571,4286. So it's going to be 571 in this case, volts. All right, so that's it. That's it. All right, so that is the application, 11 marks for that. So I just wish, guys, you know your diagrams, and I just wish you guys you revise your diagrams, know the application of each and every diagram and the formulas that are used on each diagram. But for this one, that is how we're supposed to attempt our question. Let's see if we can have more questions.